Hey, what's going on, Math 2? We've got our last lesson of the semester. Yay! So anyways, we're going to do surface area and volume of a sphere. And I'm going to go a little bit off track of the book. So here we go. So I don't know if you've ever taken apart a baseball, if you're destructive like that or something. But you may have noticed that when you take apart a baseball, the outside of the baseball is made up of two pieces of fabric that look like this. So we're going to kind of use this to figure out what the surface area of a sphere is, because obviously a baseball is a sphere. And so this would be what the outside of the sphere is made of. And I don't know if you can see this, but this section here is kind of like the connector, like over here. If you would reduce these sections down, so if you had a smaller section, that would increase these sections out here. And what you would get is this piece of fabric would eventually turn into one circle over here and one circle over here. And then on the other one, if you also reduced this section here, that would increase these out sections over here. And what do you have on your baseball? You've got 1, 2, 3, 4 circles. There's 4 circles on the outside of your baseball. And so we can say that the surface area of a sphere, like our baseball here, is 4 circles. 4 pi r squareds. So the surface area of the sphere is 4 circles, or 4 pi r squared. Part B, we're going to look at the volume of a sphere. Now we said that the surface area, the outside of the shape, is 4 pi r squareds. Now we have said before that volume is the base area times the height. So where is the base in a sphere? Well, the outside is the base. So the whole outside is your base area. So our base area is 4 pi r squared. So what's your height at this point? Well, your heights, all of your outside portions are kind of all pointing to one section. They're all pointing inwards, towards the middle of your sphere. Therefore, all of your heights are radii. So these are radiuses. So our height is a radius. So we've got base area times a radius. Now let's think back to the cones and the pyramids, because this is more like a cone or a pyramid versus like a cylinder or a prism, because all of these heights are pointing to the same spot. They're all going to the same exact spot, so they're kind of meeting at one point, kind of like our cones and our pyramids. Can't think of words today, and that was the bell. Anyways, so all of those shapes, we learned that if you meet at one point, you lose 2/3 of your shape, or you keep 1/3 of your shape. So this is the last part of our formula. So this is the formula for the volume. We can kind of put it together. 1/3 times 4 is 4/3. Pi r, and then r squared times r is r to the third. So there's our volume formula for a sphere. 1/3 4 pi r squared, there's our base area. It's 1/3 because they're all meeting at one point, kind of like the pyramid and the cone. And then our heights, these are all heights of a radius. So there's our two formulas. The outside, 4 pi r squared. The inside, the volume of the shape, is 4/3 pi r to the third power. All right, a sphere, a cylinder, and a cone have the same height and the same radius. Draw and label all three shapes. Okay, so let's start with a sphere. Sphere. So the radius is the same on all these. Then a cylinder. This one has a radius that's the same. And then we've got a cone. Radius the same. Now it says the heights are all the same. Height, height, but the height here is the diameter, so that would be 2 radii. So the height is actually 2 radii. So we're going to say that this is 2 radiuses and this is 2 radiuses. All right, so let's look at the volume for this sphere. And we know that that is 4/3 pi r cubed. So that's the sphere. Let's look at the cylinder. Cylinder would be the base area of pi r squared times the height of 2r. So putting this together, we get 2 pi r to the 3rd power. And let's do the cone. Cone would be 1/3 base area of pi r squared, and then times a height of 2r. 2r. All right, so here we've got 2 times 1/3 is 2/3. And then pi r to the 3rd power. So there's our volumes of each of them. Again, we don't know what the heights are or the radiuses are. But if a sphere and a cone are filled with water, so if I take this one and fill them with water and pour them into the cylinder, how full will the cylinder be? Well, our sphere, we said, was 4/3, pi r to the 3rd power. Our cone is 2/3, pi r to the 3rd power. So what's 4/3 and 2/3? Well, that would be 6/3, which would be 2. And what do you know? That's exactly what the cylinder was. The cylinder was 2 pi r to the 3rd power. So if you take a sphere and a cone, fill them with water, and pour them into the cylinder, it's going to completely fill up the cylinder, exactly to the top. So the cylinder will be 100% full. A sphere has a volume of 7,776 pi. What's the surface area of the sphere? So this is our volume formula. So volume is equal to 4/3 pi r cubed. And we're looking for the surface area, which is 4 pi r squared. So I need, dang it, stupid bell. That's the bell. So I need r in order to find the surface area. So what I can do is I can use opposite operations to isolate r over here. So how do I get rid of 4/3? Well, I multiply by 3/4 because the reciprocal That will cancel out the 4 and the 4, the 3 and the 3. So if I take 7,776 and multiply by 3/4, I end up with 5832. Okay, I can divide both sides by pi. And now I have 5832 equals r to the third power. And what's the opposite operation of the third power? It's the third root. So I can take the third root from both sides. And the third root of 5832 is, nope, did that wrong. The third root of 5832, there you go, is 18. So r is equal to 18. So now we can plug in 18 over here into our surface area formula. We can square 18. We get 324. Four times 324 ends up being 1296. So our surface area, the exact answer, is 1,296 pi centimeters squared, because our units in area are squared, whereas the units in volume is cubed. So this is the exact answer. If we wanted an approximate answer, we would just take 1296 and multiply it by pi. And that is approximately, rounded to the nearest whole number. If you plug it into your calculator, the surface area is approximately 4,072. So exact answer has pi in it. That number cannot be written down because pi goes forever. So it comes out to about 4,072. Last one, a hemisphere is half of a sphere. So we've got, let's see how well I can do this. That came out okay. So here we've got a hemisphere, which is half of a sphere. It has a radius of 6. Find the volume and the surface area. Let's start with volume. So volume is normally, for a sphere, 4/3 pi r squared. Not squared, cubed. Now in this case, since we want a hemisphere, and that's half of a sphere, I have two options. I can do this and then divide by 2. Or I can just say, okay, what's half of 4/3? Well, half of 4/3 is 2/3. So a hemisphere would be 2/3 pi r to the third power. 6 times 6 times 6, I think that's 216. So we would get 216, seriously? Okay, good. They decided not to do that. It ends up being 144. And then we could, of course, find an approximate answer for that. So it's half of a sphere. Now, the surface area is a little bit different. You might think, well, the surface area formula for a sphere is 4 pi r squared. So if I'm doing half of a sphere, I should get 2 pi r squared. Almost. The outside portion out here, that is 2 circles. But now that we've cut it in half, we have a new flat area, a new face. We have a third circle on the bottom as the base now. So if we're counting the bottom of this hemisphere, there's 2 circles on this rounded portion, and then there's a second flat circle, or a third flat circle down here on the bottom. So a hemisphere actually has 3 circles. So we would do 3 pi times 6 squared. That's 3 pi times 36. And was that 108? I think so. I'm just going to go with that. 108 pi is our surface area. And that would be in inches squared. So it all depends on hemispheres. Sometimes, depending on the problem, we do count this bottom section. In that case, we're going to use the 3 pi r squared. In another section, let's say that in other instances, let's say that this was like an ice cream cone and we wanted the total surface area. Well then, of course, because we're combining these two shapes, we would only use this outside portion, which would be like the 2 circles, and we wouldn't use the inside portion. But if we're just looking at the hemisphere, there's 2 circles on the outside, and then that bottom flat face down there is our 3rd circle. All right, that's all I got. There you got spheres, you got their surface areas, you got your volumes, and we are done with math for this year. Congratulations, math hard.